Okay, question 7b. Low acidity vitamin C tablets are less acidic than tablets containing just vitamin C. A student dissolves a low acidity vitamin C tablet in water. The tablet contains a mixture of 300 milligrams of vitamin C and the sodium salt of vitamin C. The pH of the solution is 4.02. Calculate the ratio of C6H7O6 minus to the associated acid C6H8O6 in the solution and show your working. So if you look at the bottom, you've got there already the workings of the ratio. So we've got the C6H7O6 minus over the C6H8O6 equals something over 1. Now if we look at the numbers we've been given, we have got the pH value. So from pH we can work out the concentration of hydrogen ions. We also know the Ka value for vitamin C. It was given to us previously in the question. So using those two values and the relationship between Ka and the dissociation of the acid, we can solve this problem. So let's start off with the hydrogen ion concentration. Okay, pH of 4.02. So therefore, the concentration of hydrogen ions is going to be equal to 10 to the minus 4.02, which is 9.55 times 10 to the minus 5. So in this mixture including vitamin C, we know we've got a hydrogen ion concentration of 9.55 times 10 to the minus 5 moles per decimeter cubed. So if you remember the Ka value for vitamin C, if you look back at the previous page, you can see your Ka value is 6.76 times 10 to the minus 5. So what we need to do is figure out how we can play around with the Ka value and the hydrogen ion concentration so we can get a relationship between these two numbers and this ratio here. So if you think about your expression, Ka is equal to H plus C6H7O6 minus over C6H8O6. Now we know this number and we know this number, and you can see there is definitely a relationship between these two and these two. So we can rearrange the equation to give us a relationship between Ka and H plus equaling this value. We can see it's already there, the same ratio there and there. So we can rearrange it just by simply dividing this side by hydrogen ions to the same to that. So Ka over H plus is equal to the concentration of C6H7O6 minus over C6H8O6. Now we know these two numbers. Ka over H plus equals this relationship, which is down there. So Ka, 6.76, let's move it up a little bit, times 10 to the minus 5 over 9.55 times 10 to the minus 5 is equal to these two things. So as long as we just do that division, we're going to have the number that goes on top there. And that is all you have to do. So 6.76 times 10 to the minus 5 over 9.55 times 10 to the minus 5 gives us 0.7078. So if we round to three significant figures, 0.708 over 1.